Lesson number 2 has two objectives. The first one is to be able to identify and describe the properties of angles, polygons, triangles, and quadrilaterals. And the second objective is to be able to determine the measurement of an unknown angle of a triangle when you are given the other two angles. So, starting at the beginning, we're going to first deal with angles and properties of angles as well as polygons. And this is going to be a more vocabulary heavy math lesson, so definitely be writing down all of the vocabulary terms as we go over them, and probably pictures are helpful as well. So starting with the angles, we have four different types of angles. The first two I'm going to start with are right angles and straight angles. And so here I've drawn a pair of perpendicular lines, and they are called that because they create these right angles. So a right angle is 90 degrees. And if you place two right angles next to each other, they create a straight line, which we call a straight angle of 180 degrees. Our other two types of angles are acute angles and obtuse angles. And so here with this pairing of lines, it creates two acute angles and two obtuse angles. So an acute angle is going to be between 0 and 90 degrees. And I like to remember it because it's little. Oh, it's a little cute angle. How cute, it's so little. So that's a way you can remember acute angles as being the smallest ones. And then on the flip side, obtuse angles are going to be your larger angles. They're going to be between 90 and 180 degrees. And that between is important because if it is right on the dot 90 degrees, that's a right angle. And if it's right on the dot 180 degrees, then it is a straight angle. Another thing to note is that all circles contain 360 degrees in them. So if I were to draw a circle right here, you can see how it's comprised of 1, 2, 3, 4 right angles. And so 90 times 4 is 360. Moving over to polygons, I think you can see all of those. All right, so the term polygon technically means many angles. And so it's a shape that has multiple angles, multiple sides. Polygons are named for the number of sides that they have. And so, for example, all triangles have 3 sides. Okay, so you can count, you've got 1, 2, 3 sides. They also will have a corresponding number of what is called vertices, and that is just the endpoints. So we've got a vertex here, a vertex here, a vertex here. You see that there are also 3, and the plural of vertex is vertices, okay? And so moving on from triangles, our polygons with 4 sides are called quadrilaterals, and a little bit later we'll talk about some different types of 4-sided polygons, quadrilaterals. And so you notice also there are 4 sides, there are also 4 corresponding vertices. A pentagon has 5 sides and 5 vertices, etc. We'd have a hexagon with 6, a septagon with 7, an octagon with 8, and so forth. Some other important terms to know regarding polygons are these 3: equilateral, equiangular, and regular. So these are some special types of polygons. An equilateral polygon means that all of the sides of the polygon are the same length. Okay, so I drew an example here where all of the sides, to the best of my drawing ability, are supposed to be the same length. An equiangular polygon is just what it sounds like. So it's a polygon in which all of the angles are equal to one another. So again, I drew, to the best of my drawing ability, an example there. All of the angles are equal, but you can see that the side lengths are different. Okay, so equiangular, all of the angles are equal, but the sides are different lengths. Equilateral, all of the sides are equal, but the angles are not all equal. And then when you combine both of these together, we get what's called a regular polygon, and that is a polygon in which all of the sides and all of the angles are equal to one another. So a square is another great example of a regular polygon because it's got all of the same side lengths and all of the angles are equal to one another at 90 degrees. Moving on to quadrilaterals. We've got 5 different types of quadrilaterals, and for each one you are going to want to write these down and possibly draw some examples as well. So the definition of a parallelogram is that it's a quadrilateral that has 2 pairs of parallel sides. So you can see in this example here, the horizontal lines are parallel to one another, and these lines that are more at an angle, I guess we could call them the vertical lines, are also parallel to one another. Next up, a trapezoid. A trapezoid has 1 pair of parallel sides, okay? And if it has 2 pairs, then it's a parallelogram. So only 1 pair of parallel sides. You can see here in this trapezoid that the 2 horizontal lines are parallel, and then these lines are not parallel, right? So if we were to extend them out, they will intersect, okay? They are not parallel. A rectangle is a type of parallelogram that has 4 right angles, okay? So a rectangle is a parallelogram because it has 2 pairs of parallel sides, just with the extra bonus feature of having 4 right angles, okay? And again, a right angle is equal to 90 degrees. Next up, we have a rhombus. A rhombus is also a type of parallelogram, and its bonus feature is that it is equilateral. Okay, so again, all of these sides are equal to one another. Okay. Lastly, we have a square. A square is a type of rhombus, so that means it's also a type of parallelogram that contains 4 right angles. So you may have picked up on this, but these 3, rectangle, rhombus, and square, are all special types of parallelograms. And then we've got the trapezoid kind of over on its own. Okay. Lastly, we have triangles. So a triangle is another type of polygon. So quadrilaterals are polygons with 4 sides. Triangles are polygons with 3 sides. And we can specify types of triangles in a couple different ways. One is by their angles. Okay, so we've got 4 different types of triangles that are specified by angle: right, acute, obtuse, and equiangular. Okay. I'll actually start with this one because we've talked about this already. Equiangular means that all of the angles are equal to one another. And then for these 3, a right triangle just simply means that it contains a right angle. Okay. An acute triangle has all 3 of its angles are acute, so between 0 and 90 degrees. And an obtuse triangle contains 1 obtuse angle. In that case, it's this one. We can also specify triangles by their side lengths. And so we have equilateral, isosceles, and scalene. So in an equilateral triangle, all 3 side lengths are equal to one another. In an isosceles triangle, 2 of the side lengths are equal to one another, and the other one is different. And in a scalene triangle, all 3 of the side lengths are different from one another. Lastly, in orange, we have our second objective, which is to be able to determine the measurement of an unknown angle in a triangle when we are given the measurements of the other 2 angles. So we've got an example here. This is an obtuse scalene triangle. And we are given 2 of the angle measures, 130 degrees, there's our obtuse angle, and 30 degrees, and we are asked to find the remaining angle. And here is the main trick or rule that you need to remember. I shouldn't say trick. Rule that you need to remember regarding triangles and their angle measurements. And it's right here with the star by it. The sum of the measures of the angles in any triangle is always equal to 180 degrees. Okay, no matter what type of triangle you have, you take the measures of all of their angles, they will add up to 180 degrees every time. So what that means is for this triangle and this problem where we need to find this missing angle measurement is we are going to know that these add up to 180, right? And so that means we can subtract the angle measurements that we have already been given, So we'll subtract the 130, and then we'll subtract the 30, and we are left with 20 degrees. And then you can check your work, right, by saying, okay, if I add up 20 plus 130 plus 30, do I get 180? Yes. So that means that you have solved that correctly. Now, this other triangle over here is a little interesting because at first glance it looks like, oh, they only gave us one of the angle measurements and then we have two unknowns. So this is the other key piece of information to know about triangles, and that is that the angles opposite the sides of equal length also have equal measure, okay? And so you can see here these little hashes that says that these sides are congruent, they are equal to one another. And so once we know that information, that these two sides are equal, that means that the angles opposite of those sides are also equal to one another, which means that this angle right here that is called x, we now know is also 50 degrees. With that information now, we can solve for y. We know that all three of the angles, when they're added together, will equal 180. So we can take 180 minus 50 minus 50, and we are left with 80 degrees for y. And you can check your work by doing 80 plus 50 plus 50 and getting 180.